To the next question. Determine the current through the 5 ohm resistor. Alright, so where's the 5 ohm resistor? It's over here. This is the 5 ohm resistor. Okay, so the question is determine the current through the 5 ohm resistor. Okay, so here the circuit is very small. Let me draw the circuit one more time so that I can mark the mesh current very easily. Okay, so wait. Okay, this is 4 ohm, this is 10 volt, this is 1 ohm, this is 8 volt, this is 2 ohm, this is 3 ohm, this is 5 ohm, and this is 12 volt. Okay. Oh, and I also forgot to tell you, now it is better that you pause this video and try to do this question by yourself. Okay, try to do this question by yourself, and then after that, after finding the answer, then you can just look at my video and see if you have made any mistakes. Okay, in case if you have made any mistakes, learn where it is. Okay, and try not to repeat that in the next problem. That is the best way to learn. Okay, so it's good that you make the mistakes now itself, so that you'll be able to learn where you made the mistake, and then along with that you can rectify it in the next coming problems. Okay, that's the best way to learn. So learn to do this problem by yourself. Okay, so now let's do this question. As usual, the first step is that I'm going to mark each and every mesh with my current direction, and of course you can mark any current. You can give the name of the current any way you want. Okay, it does not has to. It can either be I1, I2, I3, or this can be I1, I2, I3, or anywhere. All right. The only difference is that the final answer will always be the same depending on the mesh current. Okay, the final answer will be always same, because here they say find the current through 5 ohm resistor. So suppose if I mark this as I1 and this as I2 and this as I3, then the name of my current flowing through this 5 ohm resistor is I3. Okay, so that means the question is I3 itself, finding I3. That's the question over here. All right, so let's do this question. So first I write the equation for mesh 1. Now the everything will be the same. Now the procedure for this remaining process or the remaining problem is the same. Equation for the mesh 1. Right, so here I1 touches 2 plus 1, so 3, so therefore it is 3I1, and I2 touches only here, so it will become minus I2, and here I3 touches only this resistor, so it will become minus 2I3, and this voltage source is creating I1, right? So it is 8, equal to 8. Okay, like I said before, which mesh current are you writing? That corresponding current will be positive, and the remaining currents will be considered as negative. That is why I1 is positive and the remaining current I2 and I3. That is the benefit of marking every current in the same direction. Okay, now next is equation for mesh 2, right? Mesh 2, that is this one over here. So here I1 is touching over here, so it will become minus I1. Okay, and then I2 is touching 1, 4 and 3. 1 plus 4, 5, 5 plus 3, 8. So it becomes plus 8 I2, and I3 is touching only this, so it will become minus 3 I3, and there's a voltage source over here, and this voltage source is creating current. This is also generating current. The positive terminal I2 is flowing this direction, right? So which means in this direction, which means from the positive terminal. So this is also positive, because this 10 voltage is supplying I2, right? That's why. Next is equation for mesh 3. Equation for mesh 3. Okay, and in mesh 3 this is I1. So in mesh 3, I3 is positive and the remaining currents are negative. So here I1 is negative. So you have minus 2I1, we have minus 3I2, and then we have 2 plus 3, 5, 5 plus 5, 10. So we have plus 10I3, plus 10I3, okay, is equal to, and what about the voltage source? There's a voltage source over here, right? It's called as 12 volt, and this voltage source is positive terminals over here, and I3 is flowing like this. I3 is flowing like this, which means this positive terminal is actually generating current I3. So that means it is plus 12, okay. So now I can write the equations in matrix form, right? So writing the above equations in matrix form, comma. So I have over here as the 3 equations, so 3 rows. First row is 3 minus 1 minus 2. 3 minus 1 minus 2. Second row, minus 1, 8 minus 3. Minus 1, 8 minus 3. Third row, minus 2 minus 3, 10. Minus 2 minus 3, 10. This is my coefficient matrix, and then the unknown variables are I1, I2, I3 is equal to, and your matrix for the voltage source is 8, 10, 12. 8, 10, 12. Right? So now I found my matrix form. So now I'm going to find the value of I1, I2 and I3. Okay? So the value of I1 is determinant of, and here the first column will be replaced with my voltage source column. So 8, 10, 12, the remaining will be the same, minus 1, 8, minus 3, minus 2, minus 3, 10, divided by, and the next, the denominator will be the coefficient matrix, determinant of the coefficient matrix itself. 3 minus 1 minus 2 minus 1, 8 minus 3 minus 2 minus 3 and 10. Okay, so expanding this, so it will become 8 into 80, and this is 9, so it is minus 9. Okay, minus of minus is plus, plus 1 into, and this will become, let me see, 100, right? 100, and this is minus 36, so minus of minus plus, so it will become plus 36. Okay, minus 2 into, and over here it will become minus 30, let me see, yeah, minus 30 and minus 96, right? Minus 96. Okay, divide by, and for your denominator it is 3 into, here it is 80 minus 9 again, plus 1 into, let me see, minus 10, let me see, minus 10 minus 6, minus 10 minus 6, minus 2 into, it will become 3 minus 16, so it will become plus 16, 3 plus 16. Okay, this is the value of I1. Therefore I1 is equal to, let me see, 8 into 80 minus 9 is 71, plus 136, minus 2 into, and over here we have minus 126, right? Minus 126. Okay, divide by, that's the numerator, and denominator it is again is 3 into 71, minus 16, and this is 19 into minus 2 is minus 38. So you have minus 38. Okay, minus 38. So we have the answer as, let me see, So first I'll find the numerator. So numerator is 8 into 71, 8 into 71 plus 136 plus 136. Okay, this is minus of minus, so I can consider this as plus. So it will make my problem very easy, right? So it will become plus 2 into 126 is equal to 956, right? 956. So this is 956 divided by, and as for your denominator is 3 into 71 minus 16 minus, I forgot to bracket over here, there, 3 into 71 minus 16 minus 38, so you will have 159. So therefore 956 divided by 159, and you have the answer as 6.012 amperes. 6.012 amperes. 013 is 013 amperes. Okay, is the value of I1. Now the value of I2. I2, the second column will be replaced with this, right? The remaining will be the same. So 3 minus 1 minus 2, 8, 10, 12, minus 2, minus 3, 10, divide by, and your denominator will be the same. That is 3 minus 1 minus 2 minus 1, 8 minus 3 minus 2 minus 3, 10. Okay, so here it will become, expanding this, 3 into, you have 10 to 10, we have 100, and then this is minus 36, so plus 36, I believe, right? Plus 36, okay. Minus 8 into, this is minus 10, minus 6 again, right? So I'm going to take this minus 16. Then we have minus 2 into, and we have minus 12, let me see, minus 12 plus 20, right? Okay, divide by, and you don't have to find the value of denominator, right? You already found it is 159, so divide by 159. Okay, so this is equal to, let me see, this is 3 into 136, and this is minus of minus becomes plus, and this is 8 into 6 is 48, so 8 4, so it will become minus plus 128, right? 128, and here you have minus 2 into, and this is 8. Okay, divide by 159, so this is equal to, therefore I2 is equal to, let me see, the numerator is 3 into 136, okay, plus 128 minus 16, right? This is 520, so we have 520 divided by 159, 520 divided by 159, and you will get as 3.27 amperes. 3.27 amperes. Okay, so I found the value of I2. Now next is find the value of I3, right? And for I3 is equal to, and you have here, replace the third column with this, so it will become 3 minus 1 minus 2 minus 1, 8 minus 3, and the third column will be 8, 10, and 12. Okay, divide by, and your denominator will be exactly the same, that is 3 minus 1 minus 2 minus 1, 8 minus 3 minus 2 minus 3, and 10. Okay, so this is equal to, you will have 3 into, and 8 into 12 is 96 plus 30, right? Yeah, plus 30, right? minus of minus is plus, plus 1 into, and we have minus 12 plus 20, okay, and you have plus 8 into, you have 3 plus 16, which is again 19. The whole thing divided by, the denominator will be the same, that is 159. All right, so this is equal to, let me see, what do we get over here? The denominator will be, sorry, the numerator will be 3. Let me find the whole answer itself, right? So in that case I can save that much space. So this is nothing but, let me see, 3 into, this is 126, 3 into 126, and plus, and what do you have over here? You have 8 plus 8, right? Am I correct? Yeah, plus 8 plus, and what we have over here, 8 into 19, 8 into 19, that's it. That's the numerator. Divide by, and your denominator will be 159. So we have 3.384 amperes. 3.384 amperes. Okay, so now I found the value of I1, I2 and I3, and the question is, determine the current through the 5 ohm resistor, and the current through the 5 ohm resistor is I3. Therefore, current through the 5 ohm resistor is equal to I3, which is equal to 3.384 amperes.